Okay, so looking at number one, it's a positive term series. So, I'm going to use the ratio test again, hope for the best. And what does it give you? I write this down. It's absolute value e to the n plus 1. Then you're going to get n plus 1 factorial. Then you can get n plus 1 to the n plus 1 times, I like to do the multiplication, by the way, the reciprocal, n to the n, e to the n factorial. So you know what? I know I have to do the limit as n goes to infinity, this guy over here, and hope for the best, by the way. Absolute value disappears, by the way. And this really does work out really nicely, by the way. You get e. Let me write this on the outside now. Well, that's done. Let me do the factorial. You get n plus 1. So I just did this business over here. And then I'm going to do this thing over here. And what does it look like? It looks like I got n plus 1. It looks like the last problem, doesn't it? And then it's going to be times, let's see, n over n plus 1 to the minus n. Boy, this really does look like the last problem, doesn't it? What do you get? E. And then you get limit n goes to infinity. You're going to get n plus 1. I'm sorry, I made a mistake there. I was thinking forward. I don't want to think forward. That was n. Sorry about that. So n plus 1 over n to the minus n. And what does it give you? E, limit, n goes to infinity. And then what do you get over there? This would give you 1 plus 1 over n minus 1 times n, which is going to be e times e to the minus 1, which unfortunately is e to the 0, which is 1. So the ratio test really is inconclusive. It didn't help me at all. So if it doesn't help me at all, what I would, kind of put down is, you want to show that the terms are increasing. Right? You want to show the terms are increasing. All right? So if they're increasing, I always say this is difficult sometimes, especially with these n factorials and n's in it, increasing. It just things all over the place. I need to show this. How do I do it? I write it down. I want to show it's increasing. Again, what I'm trying to show it's decreasing. Okay, so what do you do over here? You put down n plus 1 then. Got this, got this, got this. I need to simplify it. All right? How do you do that? Well, I think I would, let me just make sure what I'm going to do. I'm going to erase this over here. And I'm going to divide both sides by e to the n. And what would you get over here? You get e. And then I got that n factorial business, don't I? And so if I were to divide both sides by n plus 1 factorial, you would just get n plus 1 in the bottom. All right? So what I just take up there, these two items here. All right? And then I get this old business over here. Let me see if I said that right. N to the n plus 1. Let me write that down. Oh, you know what? I see a mistake in my notes, by the way, and I apologize for that. I got to correct it. Let me erase this over here. I want to correct my notes before I move forward, though. And hopefully I can remember to put this down. This is n plus 1 to the n plus 1. Sorry about that. I do need to correct that. I didn't notice it was there. So what do you get over here? You get n to the n, and then you get n plus 1 to the n plus 1. What does that give me? N plus 1 over n to the n times n plus 1. Let me write that down. N plus 1, and then I get n plus 1 over n to the n. These cancel off, and we're left off with 1 plus 1 over n to the n less than or equal to e. And you should realize that this point over here, as n goes to infinity, that this is a true statement, by the way. And why is that? This over here, as n goes to infinity, is going to come from the bottom of e. So e is going to be up here somewhere. And this function over here is going to look, again, I'm not saying it's a great job, but it's going to come from the bottom. It's always going to be less than or equal to E. So what have I shown? I've shown that the terms are increasing. They're increasing towards the number E. All right. So what do I know about this series over here? It diverges. All right. I've got another, my opinion over here, and this is my opinion, may not be yours, or anyone else who's doing these problems over here. You could also show that this limit doesn't exist, by the way. All right. Thank you.